Welcome to Renaissance Charge Videos. I'm Rick Friedrich. Today we're going to look at the Cellulizer, which is our 2-volt rejuvenator charger. It's our biggest chargers for small batteries all the way up to your forklift batteries. This is the charger that will restore the batteries that can't be restored. So over the years, for 10 years we've been selling rejuvenator battery chargers that allow you to restore roughly 80% of the useless batteries that are out there, or prolong your batteries, keep them indefinitely. But once in a while we can't restore a certain battery. One of the cells is needs serious work. So what we've done is designed a new charger that is better than all the rest of our chargers and really focuses on one particular cell. So what we have today to show is two examples. On the smaller scale, we have a starter battery here, an interstate battery, and what we found was with our regular rejuvenator, this happens once in a while where one of the cells just gets seeming to get worse and worse over time as the other cells get better. So we have a 10.5 volt battery that's excellent for 10.5 volts, but for the one cell it doesn't come back. So this is, like I said, roughly 20% of the time we find this kind of scenario, or worse, where there's internal damage to the battery that of course can't be replaced or fixed. So the Cellulizer will then focus in on the particular cell. Now generally people are going to buy this product for these bigger cells like this forklift battery here, but it also has 6 power settings to go from 50 amp hour batteries, which is like your car battery, all the way up to 2000 amp hour batteries, which is your big cell phone tower batteries. Your big solar batteries. So today we're going to show the forklift charger, or forklift battery being restored one cell at a time. So let's look at a couple of things. First of all, it comes with a manual that you're going to need to go over to know the safety hazards and the proper operating instructions. So the general features of this charger is that it is a rejuvenator, sorry, and it is also a charger. So here we have just the empty case with the label on it, and we're going to go over some details here. So the general options are between charge mode or load mode. So the charge mode just operates as a one-time charge. Once the charging is done, the green light comes on. And this is the same as our 12 and 24 volt rejuvenator options. And so yeah, so the charging just comes on, and then the green light comes on once it's done charging, after it's figured out this is charged as much as really it can charge. But in the cycle mode, this allows you to first load down the battery to determine its actual capacity in amp hours, and then it will then rest for a period of time till the battery is cooled off and is stabilized. This is a new feature that we don't have in our other rejuvenators that do the load cycling, and this we found to be an improvement, and it's better for the battery. So it will rest and then it will charge again. Well, it will start to charge for the first time, and then it will load the battery down for the second time, and then it will compare, after it's finished loading the battery down, it will compare the amp hours that the first cycle gave to the second cycle. And if there is a gain in the second cycle, it will continue for a third cycle. So it will again charge up the battery after it's loaded down automatically, whether it's finished or not. It will charge it up at least one more time. If it's determined in the previous load cycle that there is a gain, a significant gain from the first one to the second one, then it will go again for a third time, and so forth. It will continue on as long as there's a significant gain. Now usually it's the first load charge cycle, there's going to be the biggest gain. And then with this particular charger, there's not as many cycles needed. The first charge really brings back the battery the most dramatically, even more than our other chargers did. So what happens is it will just continue to do that as long as there's a significant gain, and after a while, it will level off. Generally there should be still little gains continually. So anyway, it will then eventually conclude that there's no more significant gain. It will charge it one more time, and then the green light will come on. Now you don't have to wait for that. We've seen with this charger, actually every single battery that this charger has been on so far has brought the cell higher than the original capacity. And we've really never just continually ran this charger on a particular cell as we move on to other cells. It takes quite a while for this charger to work on these really big batteries because we incorporate quite a long rest period, and we very carefully charge it. So that's the operational description of this. So there's an on and off switch, of course, here. There's a power selection button here, and then there's an LCD screen, which we're going to look at on this model here. And so, unlike our previous models that we had with the 12 and 24 volt models, we didn't have an LCD screen, we just had a voltage display. Now this always displays the voltage, but it also will display what the other charger had with the computer readout. It will display that on the LCD screen as it's happening, and then it will tell you the previous load amp hour ratings. While it's charging, it will tell you it has so much capacity in amp hours. So just like the previous models for the 12 and 24 volt models, you still have the computer serial port connection on the back that you can go to a USB port with a suitable adapter, or you can use it on an old computer, the oldest ones you can find, and just use a basic data logging program, which we recommend a free downloadable program. That way you can monitor on the computer a little bit more detail than the LCD screen provides, and we also have the capability of logging, and so that we can store all the information. So most of the people that want this charger are engineers that would like to show statistics to their boss to justify the buying of such equipment, and then they can have peace of mind and know exactly what the particular cell started off as in amp hours and what it finished as, and then they can get into a routine maintenance every so often just go through all the cells individually. So in this particular case, these cells here are at zero capacity. This forklift, after charging it for days with a regular charger, will only allow it to move very short distances and do very light lifts. It will not even be able to move up an incline. Transporting this forklift was actually very difficult because of that. It was not able to actually move up the ramp. So that's how bad it was. It was probably at 5% capacity a year ago, and then it sat for 9 months uncharged. Now we did attempt to charge it with the 12-volt charger and 12-volt sections. This is a 36-volt battery here, and it responded. Now we didn't charge it with a big enough charger, but we attempted to charge it slowly with the other chargers, and it had minimal success. So these cells were really, really bad, and we could have worked on it more, but I was trying to save it for this particular charger as an experiment. So it sat for at least 9 months, and then the batteries were then at zero capacity. So what I did was, and I show this in the logging here, I ran it for several hours on the highest setting, and then I attempted to just to see the response initially. It wasn't a proper test, but the point is that it gave 100 amp hours without fully charging. Of course, it was only charging for a short period of time. And then what I did was run it a full, after it's discharged, I ran it for a full charge. I started it over again on the 5th setting, which is more appropriate. This is about 1,000 amp hour battery bank here, and so I didn't really want it on the highest setting because I wanted a more accurate proper setting. As you can see on the label, we have different power levels which we can select with this button here. So level, let's go through the levels here. So you can see the various levels. Level 1 is 50 to 100 amp hours, level 2 100 to 200, 3 200 to 400, 4 400 to 800, 5 800 to 1300, which is what this is more appropriately, and then level 6 1300 to 2000 amp hours. So I chose that setting, and then I put it, and then it loaded it down, and then it gave me it gave me the 100 amp hours with the first charge for a couple hours, and then I went into load mode again at level 5. So immediately brought the batteries down because it had already been discharged and it hadn't been recharged. And then I put it on level 5, so then it went into charging mode. So now it's just finally come to a stop of the charging, and so it's at a rest stage right now. And when I was actually trying to set this up for this video, I disconnected the little wires, and I'll show you these little wires now, and I'll explain in more detail the details of this setup here. So what we have is your main wires here, which are pretty pretty thick wires here coming to the battery terminals here, and we're going to go over this in a little bit more detail. Actually, I might as well do that right now. So let's go over some of the details. So we have, coming out of the back, these wires here, and we have a unique clamping system here. You can't use regular alligator clip clamps that you find with your jumper cables or so forth, because this is very high amperage. It can get up to 175 amps on the charging or loading cycles. So what we do is we clamp onto these big bus bars here with aluminum and some bolts. Now this is just a crude setup here, not the right length of bolts or whatever, but we really want some very strong connections here. Otherwise, if you make a weak connection, they will heat up at that connection point, and you could risk fire and explosion and what have you. So we have very large terminals and connections here. Now what you see here is what I'm referring to is these little wires. Now you ask, why do you use these little wires coming out here? Because there's a voltage drop across even these big wires here, and these little wires give me more accurate voltage display. So I'm also showing on the voltmeter here that it's at 2.3 volts resting, and it has been like that for several hours. And so let's look at a couple things. So clamping, this has to be done very carefully, because if you short across these terminals here, you'll have extremely high amperage, especially once it's rejuvenated, and it will be extremely dangerous. So people should only attempt this if they're qualified or they're very careful. Now, I was a mechanic for years, so I know all about the possibility of crossing battery terminals with tools, and not to ever use jewelry, not to smoke around this, not to do many things that we talk about in the manual. So as per the instructions, once this gets running, especially at the higher power levels, what you want to do is check these terminals after a couple of minutes to see if they're heating up. Not to touch it with your hand, of course, ever, because you could make a short between yourself and the ground or something. So, but you want to check it with a temperature gauge, such as a thermal. So you can see here, this was the hottest point. It's still 83 degrees. If we go to other batteries here, that the temperature, the room temperature is only about 73, 72 degrees in this beautiful August month here. So this battery has been charging. It's not yet returned to its cooled off state, but we're not going to wait for it any longer. It's there's a time factor here that I am trying to deal with. This is a customer's charger that we're testing out. That's why it doesn't have the label on it or anything, and it's not fully assembled, because we are testing it out, making sure that everything is perfect on it. So anyway, the safety considerations are in the manual, and now a couple of details that you want to consider is the water level. So you can see here, if we look carefully inside here, in this particular one, you can see the plates Now this is a 2-cell battery, so there's only one cap and hole to access the water because there's only one cell. Now you can see it's bubbling because it's still charging essentially. It's still dealing with the fact that it was charging for over a day and a half. And well, about a day and a half it was charging, so that was its real first significant charge. Now what you want to do, especially if you have a really sulfated battery that's got no capacity, then the water level is going to be low, no doubt, but you don't want to you have to put distilled water in there, but you don't want to put too much water because it will overflow, because the water will expand as it rejuvenates and charges, and so then it will come out, and that's a problem. So you don't want to lose your acid and your water, and you don't want to have the corrosion that's usually found on these forklift batteries like that. You want to keep these clean. I haven't attempted to clean this off or anything yet. Bad example. But anyway, you want to at least cover the top of the plate. And I actually did. I didn't really go very much beyond the top of the plate, and you can see now the water level is at the bottom of the plastic. That's exactly where you want it in the end. That's really the level that you're supposed to fill it to. And now that it's fully charged, it shouldn't really rise up too much more. There should be some off-gassing every time I charge it, so you have to keep checking your water levels from time to time as periodic maintenance. Now the thing about it is, as it's charging, there will always be off-gassing, especially when it's charging, not so much when it's loaded, but and so everything in the area is going to be sprayed with a acid mist. And don't fool yourself, your clothes will get ruined. You won't notice it immediately, but in the wash you'll find curious holes. So use gloves, like I'm doing, of course, with gloves, obviously, right now. No. Use gloves, use safety glasses, because you could have a big bubble spray into your eyes and cause serious damage. So anyway, we want to be very careful in removing caps and so forth while we're charging the battery, because we wouldn't want to really touch these two terminals at the same time or risk somehow shorting out something. So you clamp on this, it's pretty self-evident. You have to remove these plastic pieces here and then clamp onto it, and then move on to the next one. I'm just starting with this corner because it was convenient, and then I'll move across. Probably should have started at the first positive post terminal there, which is usually the weakest, and then moved accordingly across. But I just wanted to do one cell first to see the response and get this off to the customer. So you ask then, how, Rick, can you actually get into the 2 volts of a 12-volt battery when you don't have the terminals exposed? And that's a good question. So if we look here at this interstate battery here, we'll find that you can always access the furthest most terminals, and then what you can do is pop off the caps and try and get into the plate through the holes and just literally drive a nail into the plate or something to secure it, a screw actually, that would properly secure it. So that I can't really recommend doing that because it's not something that I want to be liable for. So, you know, you're on your own if you want to try and do something like that, or drill through the top of the battery. If the battery's gone, you know, what do you have to lose? But essentially you want to secure two solid connections to each plate, each side of the plate, and then charge. You don't want to have any kind of sparking. Now with the smaller batteries, it'll be easier to make the connection, and you're only running at lower voltages or lower amperages, so that's not as big of a deal as this, where we're running. Here we were running up to 60 amps so far, because it still hasn't fully rejuvenated, and it can only take so much. So even if you throw a lot at it, it will only put out so much. So that is the way the system runs. I'm going to leave these wires separated, but you could run them parallel to each of the wires here. So, like as I said, you want to use distilled water in there only. You don't want to use tap water, and even deionized water, you wouldn't really want to use that. You want to use distilled, properly distilled water. So let's look at now the computer logging program. So now what we have here is the program, the logging feature, which allows you to keep the information moment by moment. So you can see here initially, well, we made this charger in 2009, and we haven't actually begin to selling it until this year. So anyway, what happens is you turn it on, and then if you have it in load mode, so you can see here that I had load cycle completed, but the amp hours were 0, and so I turned it off, and it didn't mention that in there because it didn't even supply 1 amp hour. And then I turned it on again at the different power level, and so this was at the power level 5, and then it went through, and it actually shows that it did 180 amp hours if you look here on the side, but that is because it went below the like if you think of a 12-volt battery, the amp hours are only considered down to 10.5 volts, and so that's really how the battery is rated, what kind of amps it can push or put out while above 10.5 volts. Normally you don't use a battery like in a 12-volt situation. So here, if you translate that down to 2 volts, it has its minimum range as well, which corresponds to the same as the 12. So even though it provides more amp hours, like 80 more amp hours, in the end it said on the screen that it was only 100 amp hours. So that's all it's really going by. So right now I turned it off by accident. Actually, I wanted to keep this going. It's probably better that it wasn't on while I was talking because the fans are on, but I accidentally disconnected the little wire here, and what happened was it then turned itself off. So now these have to be more secured and placed inside of the terminals and so forth. But I was just holding them on there to see where it was best to connect. So anyway, I disconnected it by accident, so I really wanted to run this through by itself, but now we'll get a chance to actually turn the machine on and watch it from the very beginning. So we have a basic logger, like I said, Terraterm, and you can download that off the internet. It will even go onto Windows 95 or earlier, and the latest computers and operating systems. So what you do is set it up, excuse me, and then what will happen is you have to turn this on first if you want to do the logging, and then you have to be able to choose. See, this is already chosen. The log feature here is already logging, so I don't need to do this again. I'm just going to start all over again, and when I create log, when I press log here, it will ask me to create a file, and then I can place that file wherever, and then it will continually write to that file, which it was doing here. And and then once the loading is done here, it will go into the charging mode, and it will actually read out these numbers. These numbers are showing that every time it charges, it goes through a cycle of charging, and then it measures the voltage, and if it sees a gain, it will continue to charge. So in this case, it did this for a day and a half, and this was the numbers it gave here in the end before it stopped and determined. You can see it went lower. Once the voltage went lower, then we know it was time to stop. So that's how that works. So we can create the file again by opening it up again. We can then look at the file as it. So you can see here error because I accidentally disconnected the wire, and then I turned it on again momentarily just to see that after I moved everything around, everything was good. So that's how this will work, and I will disconnect this and I will start it up again. But let's go through the features here. Now normally this has a label on it, as we can see right here, but I don't have it on there yet because this one we are still making. So what we have is a little LED that's going to tell us a couple of things. We have 3 different colors on there. The red flashing is when we have something not connected, the battery's not properly connected. Maybe you have a reverse terminal connection. It's very, very important that you connect this the right way, you know, and so that you got to make sure that you do that. But if there is a reverse terminal connection on the little wires, then it won't start up. So it's important to connect the little wires to the big wires here, so that that doesn't happen. But it's automatic. It won't start. The red LED will flash. So again, we have the charge and on and off feature here, which right now I don't have the on and off switch. I just have the cycle feature that is turned on and off here, and then I just have the button here. And then what we want to do is just start this up and see what the options are. Now this is all pretty straightforward in the manual here. So if I look at this here, you can see it's asking a question. It's already set to level 5. because that's the way I left it. It will return to the same level. Now you can see the voltage is at 1205, whereas this one is at 1203. There's a bit of a voltage difference because voltmeters are different from each other. So now all I got to do to switch between power levels is hold the button down just for a period of time. Once I hold it down, it will switch to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Now all I have to do is touch it with a short pulse, short push of the button, and then it will start. So this is ready now. Now if I flip over to this will change it from load to start, or load to charge mode. So what we're going to do right now is just load this battery down, and we can look at the various things. So let's actually start it up in charge mode and look at a couple of features here before we go and switch to load mode. So now we're going to see the voltage immediately start rising, and the voltage here is pretty accurate compared to the voltmeter, which the voltmeter is reading a little bit higher because it's not calibrated to deal with the pulsing as much as this charger is. But voltage is all relative. What people are after ultimately is amp hours and capacity of the battery. Now with Renaissance chargers, what we see is the battery voltage gain rise higher under rest than all other chargers out there. So that means you have higher capacity, so you have a higher voltage, and you also have a lower deep discharge cycle. You can actually have great gains below the normal operating voltage level. So if you have an electric vehicle like a forklift here or electric car, you don't have to worry that, oh, now I've hit that, you know, if you're doing a 12 volt battery bank, oh, I've hit that 10.5 volt, now it's going to drop off like normally it would. Actually, what we've seen over the last 10 years is that the voltages come down in a way that isn't just dropping off. So we see voltage gains, we see capacity gains from the very beginning to the end, and our graphs are quite a bit different. It's a different type of battery charging altogether. So now what we're going to do is use the amp hour or amp meter here, and this one is convenient. You don't want to put an in-series amp meter. So now I'm pretty close to this wire, so I'm just going to go down here, and we can see we're pushing 60 amps into this battery right now, and so what we want to do, like I said, is check, make sure that everything's good temperature wise. So this is going to start heating up again, so I don't want to really run this very long. So what I want to do is turn this off for a minute, and then let it rest for just a minute so that it can it's more healthy for the battery to let it rest, come back to an equalized position physically, the plate actually moves under charge and under load in opposite directions. So what we're going to do is charge this up and look at that. Now I could have shown this, which we'll do once we start loading it. You'll see this on the computer running. So while we're waiting, let's go over maybe this manual a little bit to see some of the details. This one doesn't have the logo on it because we're changing the logo. But you got to consider, of course, the safety precautions, eye protection, gloves, avoids flames, sparks, what have you. Hydrogen gas is produced while charging, so you have to be aware of that. You always have to ventilate a room, especially when you're dealing with such a large battery bank here. Give the hydrogen is lighter than air, so it rises, so you need to give it a place to go out. Well ventilated area. Don't put your face near it. Avoid contact with acid. And overcharging batteries. So really you don't want to get the battery above 120 Fahrenheit or 49 Celsius. It's getting too hot in that case. This one got up to 100 and about 104 Fahrenheit. Now the rejuvenation is a chemical process that will create heat. So then a couple of things, you got to properly ground this, and this is actually going to be a 220 model, 240 model. Right now I actually have it for 110, and then we will convert it over to the 220. But so it comes in two different models, 110 or 220. Now, always remove your jewelry, proper wiring, so forth. Let's look at a couple of details here. Some of this isn't as important as other points. So there's just a couple of details here. Maybe we can go over connecting it again to the proper power. Clean the terminals. Okay, so actually start off by determining which cell is the worst. So check the voltage between all the cells. And the one that's the lowest is the one that you want to focus on. Then clean the terminals properly. With a wire brush or whatever until you have a very clean surface. Excuse me. If you don't, then what will happen is you'll create not a proper connection, and it will arc, and could cause an explosion, and it will actually be not very good for the charging. So then again, fill the water up to where it needs to be, and then select the charge or cycle mode, either one, depending on what you want to do, and then turn on your computer before you actually do that, and connect the computer if you want to log it like that, like I'm showing here. And then watch again for, once it's started, watch the cables and the connectors on the terminals to make sure they don't get hot. And then make sure the cells don't get hot. We could add a feature where two wires come out of the charger that would connect to the cell for a temperature that would turn off the charger if they got too hot. So that is definitely a possibility to do. We have that actually in our other charger. Our e-cart charger has that option. So then turning off the charger, just turn off the power switch. So here's again the voltage display, and you'll see here now it's charging, cycle 1, capacity at, see this is already gone through on the load feature, on the load cycling option. It's already charged or discharged the battery, and then you can see it's at the same power level 5, cell voltage 2.47 in that case. This battery hasn't come up to that state yet, so hopefully with this next cycle we can actually get up there. Be a little LED, you can see right here, it's not where it's going to be, but once the label is placed we put the LED hole in. So then there's a troubleshooting guide if there's something in there, and then you have a place for your notes. So the input is 10 amps max on the 110 model, and the 220 model is only 5 amps max. It doesn't actually draw a whole lot of power. It is only doing one cell, but it is high amperage because the voltage is very low. So let's look at, again, starting it up in load mode now. So you can see now the voltage is still at 208, just with that little charging. It's still not come back down to that rest position yet, but we are just going to get going on this. One thing I'll say is, when we first did this charger, we had a forklift battery that we charged for years with our other chargers, and we only got 2 of the cells up to 60% capacity, and then we couldn't get them any higher until we developed this this charging technology upgrades, and we focused on the single cells, and we got those above 100% capacity. So then we've done other batteries that are even bigger than that. Was another forklift battery, the exact same size as this one, 1000 amp hour, and so I hope to see this battery come back in the same way. But in this case, all these cells are so bad that they need each one individual attention. Now, I've said this a couple of times before, but with this charger, I also brought back, a customer of mine lent me their 2000 amp hour solar batteries. And I use this charger. So these on those batteries, and what happened was they had got these batteries from, they had been discharged from the cell phone tower usage. After about 3 years, they discontinue them and recycle them. So somehow they got a hold of these batteries, and they used them for another 15 years in a home solar unit. So then what happened was I got them, and one of the cells was lower than 100 amp hours. So the whole bank was only as good as that cell, because what will happen is that battery, as it uses its power, it will actually go down to 0 and reverse voltage, which is not a good situation. So that particular battery and another one close to it were very, very bad compared to the rest. The rest were really bad too, but not nearly as bad. And I had already charged it a little bit too before I started, so it was probably lower than 100 amp hour. So you can imagine this big 400-pound cell only giving you maybe 50 amp hour. You know, what's the point? You can have one of those little car batteries that will give you that kind of capacity over this 400-pound battery. So we restored that, and I'll show the chart in some images when I finish this video. And you can see that each one of the cells that I restored only took 1 to 3 cycles. And generally they just took really 1 to bring it back significantly, and they all went over 100% capacity. And I actually switched it off before it completed on all of them because for the sake of time. It does take a while to do this. It can take 2 to 5 days per cell if it's really, really bad. If you're just maintaining it, then it can take a day just to do the charge once, or less than a day for a full charge once it's already been in fairly good condition. But anyway, we restored those batteries, and those batteries were brought back again to above new condition, and that was just ending the cycles before they actually would have kept going, and you would have had more gains on it. So a big battery like this could take a good month to do. Now, as it says in the manual, for the sake of time, it's better on a battery like this to turn it up to the highest power level the first time to go through a cycle. Like if you really want to see where it's at, then you charge it up with the regular charger and then run it and load, and you'll see the amp hours after it's loaded down. And then what I recommend is just turning it off and then starting it in the higher setting. That way it'll push it a lot harder initially, and then what you can do after that charge is let it rest, come down to temperature like it would do automatically. But in this case, we don't want to load it in setting 6. We want to load it in settings 5. So that's kind of what I did a little bit. I didn't charge it with the highest setting for very long because I wanted to just start it really from scratch. But anyway, the idea would be to push it harder initially. I mean, not on a tiny little battery. You wouldn't want to use power level 6, but in this case, going up 1 level is going to speed up the process. So let's, my voltmeter's timed out here. Let's start it up again. So we're at 207. Now we're going to start it in load mode. And then we can see it under load. If I can actually turn on this power bar. Okay, so now we can see we have this option, and all I have to do is gently push the button here. And then it will start. Oh, now it's still in charge mode, so I have to. So you can hear the click, the amp hours. See it now, it says now at 0 amp hours. So you can see the voltage automatically drop down. Under load, it's going to drop down. So it's not the resting voltage, and that's where it's difficult for you to figure that out until you know really the capacity of the battery and the load it's under to determine what the amp hours really are. It has to be calculated, which is what our computer does. So what we're going to do is show you the amp hours, or the amp on the line here, just like we had before under charge mode. Now we have it backwards. So we got 65 amps. Now I got that upside down. So 66 amps right now is pushing. Now the good news is when we did this last time, the first time, it was only pushing about 40. It was only allowing 40 amps to be drawn. So now let's look over here. We can see now it has supplied already 1 amp hour after loading for 1 minute. So because the amps were so high and the voltage was high enough, it was actually registering already an amp hour per minute. Now as the voltage goes down, the amp hours are going to, or the amps are going to go down, and the amp hours are going to take longer to consume, to be used. So we're going to go down here and see now, just like this display, it's going to, so we can see we turned it on and off a couple of times, and it was still, because the program was still on, it was registering each time we turned it on and off. And so there's no point in keeping the screen up, because as this changes, it will it'll be different. So anyway, what we want to look at now, what I need to look at, is the temperatures. So we got this battery now at 82, 83 Fahrenheit. So now under load it's not going to heat up as much, but like I said, what you want to do is make sure that these connections are good and solid and not loose, so that, and if you measure the temperature, you'll see that it's not too high. So it's holding the voltage, 1.8 volts. Now as this battery increases in capacity, it gets rejuvenated, more of the lead will be exposed, and therefore it can be charged, and it will be conditioned so that it will actually register a higher voltage. So that way it will be able to draw higher amps also, and will have higher capacity. So we can see here again, it's displaying what it's showing on the computer. Just briefly, it's showing the voltage always 181, 182 volts, and it's at 4 amp hours already. Now I don't expect it to be up to 1,000 amp hours at this point, but it did charge for quite a long time, which is a good sign. And the resting voltage at 203 is, if you make that the equivalent of a 12 volt battery, it's still only sitting at, that would only be like 12.3 around approximately. Again, the voltmeters vary from one voltmeter to the next, but we have a pretty accurate voltage calculator in our system here. But again, voltage is relative. We want to see a higher voltage at the end. So right now we're only partially rejuvenated in this battery bank, because it is the worst, probably the worst case that you'll ever find, besides a battery that can't be fixed, which is like shorted or cracked or something. So anyway, you can see the voltage is dropping slightly, but it will go all the way down to it will go all the way down to under a volt, like down to 0.6 of a volt, 0.8 of a volt, somewhere around there, I forget. So let's look at the amps again. Oops, I have to turn it up to the higher setting. So now it's pushing 63, 64 amps. Yeah, about 64 amps only, because there's a voltage drop. So the amp hours are going to go slower. Again, we can see we have 7 amp hours here, and also displayed right here because they're in the same system. So the voltage reading here is a little bit higher than my other voltmeter on the battery, because voltmeters are different, like I said. So anyway, this is a charger not for everybody. This is for industrial use. There are customers of mine that have been using these battery chargers for 10 years straight, 24/7, restoring thousands of batteries in different places around the world, not just in the United States, but in Europe and South America, Australia, all over the world. People are using these rejuvenators, and this is for people like that. If you have to pay $5,000 for this battery bank here, and you can restore it and keep it, it's not just restoring it one time, it's restoring it and keeping it for good. So long as you maintain it properly, you should be able to keep your batteries, and as long as you don't abuse them. I mean, the forklift batteries can handle the power loads that they're made for, but smaller batteries people tend to generally abuse more, so they can warp the plates more and really damage them. But generally these are sulfated and they can be restored, and now we can actually see them come back to 100% capacity, which is, or beyond. And the ones that we couldn't do before now seem to be able to do that. So I can't say that it will restore every single battery, but so far every one that we have run on it has come back above 100%. There hasn't been a lot of batteries tested with this, but we have seen phenomenal results. So the fact that we can restore batteries that couldn't be restored with the previous chargers is, to me, very important. The other chargers are great, and they have a high success rate, but when you have some really bad sulfation, and it may not be able to get through that. So we have a very delicate process where we have to not charge batteries too hard, because we could damage the plate material. Like other people who create these kinds of systems will sacrifice the integrity of the plate to remove the sulfation, and so they may have initial capacity increase, but then they've destroyed the full potential of the battery, they damage the plates, and so you might see initially success, and then down the road a year later or something, the battery's going to start failing because of the damage done by the charger. So this particular, so we've always been careful with our battery chargers not to ever damage the battery. That's the first premise of the company, is battery longevity. But this particular charger accomplishes what the other ones could not do. So it's a difficult machine to manufacture, and the price is pretty high because of the parts involved. It's just under 50 pounds, and it's so it's a pretty big unit. There is plans of making a full-size forklift charger, but that is going to be a very big machine to do, 1,000 amp hour or 2,000 amp hour batteries. We need to be able to push over 100 amps for the charger, which requires a very large transformer. We already have a very large one in here. So anyway, we're up to 13 amp hours, and we're definitely going to see the 100 amp hour again, but we will hopefully get closer to the 1,000 amp hour this time. And I think that really covers everything that I planned on talking about. Again, you'll see the amperages increase here, and we can go up to 175 amp hours on the charging and loading. Now, one other thing. So the light LED is now in an amber color because it's loading. Once it's resting, it will flash, and then it will tell you on the screen. It's saying right now loading. So it will tell you resting, and then it will tell you charging. And if there's a problem, so I'm going to look right now. This is why I have it not completely closed, because I'm monitoring the temperatures internally to make sure they don't get too high. If there is something wrong in there, then I would want to be able to notice that. Now, if it does get too hot, we have thermostatic control in there that will turn off the charger if either the transformer gets too hot or the switching gets too hot. So it is, it has its own safety features, and it does have a circuit breaker, which is not presently on this because it's not got the 220 hooked up to it yet, which has a proper circuit breaker on the back that will allow for it to trip if something went wrong. And I think that's all that I need to say today. Appreciate you watching, and let me know if you want to get one of these.